Hello guys, so again we are back with the problem, and today we're going to be learning about functional equations. And yeah, this is a really interesting problem actually, and this is from the team selection test of some country, which we will know later. And this again involves some substitution strategies. So yeah, let's see how it goes and hope you have fun. This is the problem number 11. So I believe this was the second last problem from the India team selection test in IMOTC in 2010. And in this video, we're going to be learning about a problem solving strategy in functional equations, some book sessions of functional equations, and at the end, a similar but challenging problem.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
So okay, what have they given to us? Find all functions mapping from real to reals such that it satisfies the given functional equation for all reals x, y. And f of x plus y is plus xy actually. So let me just make a correction. F of x plus y plus xy is equal to f of x times f of y. Now, how do we go about this? So this, in 2022 is a relatively known functional equation. But, okay, let's just try and see how we can find that out. So, first, again, the simple strategies. What do you do first when you see a functional equation? No matter what it is, if it's at the national level Olympiad, if it's a team selection test, one of the first thing that comes to mind is substitution strategy, right? So, for example, I can just plug in y is equal to 0 and maybe just put in x equal to 0. Let's just see what we get, right? So I'll get f of 0 plus 0 is equal to f of 0 times f of 0, right? So that essentially means that f of 0 whole squared is equal to f of 0. So f of 0 can again be 0 or 1. Well, I think let's just keep it at that. The second thing that I'm going to do is maybe plug in y is equal to 0 and x equals to x. Right, and let's just see what we get. I'll get f of x plus 0, x times 0, is equal to f of x times f of 0. And this is really nice because f of x then becomes f of x times f of 0. So I can just bring f of x to the left hand side. And this is obviously a factorizable form. So if I can take f of x common, I would get f of 0 minus 1 is equal to 0. There are obviously two cases. Case 1, that f of x equals to 0, and case 2 would be f of 0 is equal to 1. And so this essentially cancels out this case. So f of 0 can either be 1 or f of x has to be 0, right? So this can actually hold true. But that would hold true only and only if the entire f of x is 0 for all x. Right? This is for all x, by the way. So then automatically f of 0 would become 0, right? So f of 0 would be 0 if f of x is 0 for all x. Essentially, f of x is a constant function. And how do we check that? So we had this given functional equation. Now, if f of x is 0, f of y will be 0, f of x plus y will also be 0. So all of these three things are 0 essentially. Plus xy is equal to 0 times 0. So xy is equal to 0 for all x, y belonging to reals. But is that actually true? No, right? Because xy is equal to 0, which essentially means either x is equal to 0 or y is equal to 0. Both can't be 0. Or both can be 0, right? Both can be 0, but both can't be non-zero. That's what I want to say. So x not equal to 0, y not equal to 0. This will not work because xy has to be 0 for f of x to be 0. But is xy 0 for all x, y belong to real numbers? Absolutely not. So therefore, this f of x is 0 is not true, and hence this case is eliminated. Another way to really check this is if you just plug in the values of x and y just for substitution. If I just plug in x as 1 and y as 1, what do I get? I'd get f of 2 plus 1 is equal to f of 1 whole squared. But essentially, if f of x is 0, so that would mean f of 1, f of 2, f of whatever is 0, right? So this is 0 plus 1 is equal to 0 squared. So 0 plus 1 is equal to 0. That essentially means 1 equals 0, which is obviously untrue. So that means you can, again, this is another way to just disprove this case, right? So then we move on to case number 2. And what was the case number 2? It was f of 0 is equal to 1. right? We had over here, so f of 0 is equal to 1. Let's just analyze this case. And the given equation was f of x plus y plus xy is equal to f of x times f of y. So whenever really you have f of c is equal to c prime, for where c and c prime are obviously two constants, then maybe you can put y is equal to c and x equal to x. This is one of the ways to go about it, because you know the value of f of c, right? Because you know the value of c, you can just plug in that for y and x for x to try and generate some terms just purely in x. But here another thing that we can really do is, because this is f of 0, we know the f of 0, I can put x equal to x and I could put y is equal to minus x. And the intuition behind that, essentially we have an x plus y term over here, right? Something f of something which is x plus y, right? And when you put x and minus x over there as the assertion, you will get f of 0 minus x square is equal to f of x times f of minus x, and f of 0 is obviously 1. So you will get f of x times f of minus x is equal to 1 minus x squared. At this point you can plug in maybe x equals to 1. So you will get f of 1 times f of minus 1 is equal to 0. Now again we will bifurcate into two cases. Case 1, f of 1 is 0. Again let me just kind of get back to that point. F of c is equal to c prime. If you know that, plug in y is equal to 1 and x equal to x. That's always a good thing to do, right? So what will I get? I'll get f of x plus 1 plus x is equal to f of x times f of 1. F of 1 we've considered 0 for this case. So f of x plus 1 will be equal to minus x. And now that we've come over here, it's really easy to find out the value of f of x. You do nothing, but this is just standard, right? It's just standard. If you put x plus 1 is equal to t, x becomes t minus 1, right? So essentially f of t would become t minus 1. F of would be minus of t minus 1. So f of t would be essentially 1 minus t. Some people also call this Euler substitution. Okay, so f of x is 1 minus x. So that is one solution to this problem, and it's an accurate solution. It actually holds true. You can actually, for all x, you can just plug it back into the functional equation and check. F of x equal to 1 minus x is a solution to that functional equation. Now let's just analyze case number 2. So what do we have in case number 2? Well, the first case was f of 1 is equal to 0. Second case would be f of minus 1 equal to 0. Again, just a similar problem solving strategy. If you have a constant whose value is 0 or 1 or 2 or whatever like this, you can just plug that as y and plug x as x. So here I will get f of x minus 1 minus x is equal to f of x times f of minus 1, which is obviously 0. So f of x minus 1 is equal to x. Again, same idea, literally the same idea. Plug in x minus 1 as t so that you get a term in f of t, right? And so x becomes t plus 1. So f of t becomes x, which is t plus 1. So therefore f of x is also x plus 1. So yes, we have two solutions. F of x equals to 1 minus x and f of x equals to 1 plus x, and indeed both of them actually satisfy the given functional equation. So yes, that is probably a good place to stop. And so yeah, this was a team selection test problem, and all we really did here was substitution strategy and checking if this essentially works out or not. Again, the idea is a lot of people get confused what to substitute, when to substitute, but always remember, start simple. Start with something like 0, 0 is always a good idea. 1, 0, 0, 1 for x and y, assuming you have two variables. All of these are really good starting points. You can put x, 0, you can put 0, x, you can check if the function is injective, if it is surjective, if it is both, it will be bijective. These are some of the ways that you can start the problem with, right? But yeah, here again we just use substitution strategy. We started simple, and once you get to a point, for example, if you get f of c is equal to c prime for any value of c, for example f of 0 is 2, you just plug in y is equal to 0 and x equal to x and just see what that gives you. It may help out actually. You might get directly an expression in x. So yeah, that was an interesting problem, and I hope you learned a lot from it. Great, so now we have some book sessions with functional equations. Functional equations, how to solve them by Christopher G. Small. This is a little bit of an advanced book. And functional equations by B.J. Venkatachala. So these two are, both of them are really good books. And yes, after that we have a similar but challenging problem. Find all function f mapping from reals to reals. such that f of x minus y is equal to f of x plus f of y minus 2xy. And yeah, again, here you can use substitution strategy. That should be, in my opinion, more than enough. Just use the ideas that I told you. Start simple. Once you get the certain values such as f of c equal to c prime, substitute y is equal to c, x equal to x, obviously, and just try to get certain simplifications. Functional equation is essentially the art of simplifying the problem, and the more practice you do, it essentially becomes easier. So if you make any progress on it, or if you're able to solve it, let me know in the comment section below, and even if not, I'll try to help you out. And that's it from this video, and I'll see you soon again next time. Thank you very much, and bye-bye.
The programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.